So I need to put a little bit more meat around how this is actually used in the system. So if you think about the VX4C silicon platform from QuickLogic, we would connect to the display interface of a Qualcomm processor via MDDI. We would have the visual enhancement engine inside, and then we'd also connect to the display in these systems via RGB or one of the CPU interfaces like EBI2, I80, or some other generic CPU interface. Let's go into a little bit more detail on that. So also in the platform, we have frame buffer. And I want to get into the depths of display technology and why you need frame buffer. But if you have frame buffer in your platform, like we do, you can actually have the CPU send only the pixels that need to be updated on the display and then go to sleep. And then we'll update the display on our own. And the fact that we have a very low power platform with the visual enhancement engine, it means that from the system perspective, you're going to consume less energy. And batteries store energy, not power, right? So more energy efficient system, longer battery life that ties back to the user experience of these mobile devices. What's the biggest complaint about the iPhone? I have one. I have the same complaint. Okay, what's another one? Yeah, battery life. I actually have to charge this during my day, and I carry a separate battery to charge the battery inside because I can't get the battery out. So I love the iPhone, but I don't like the fact that it doesn't last the whole day. So battery life is a critical issue in these devices, and doing things like embedding frame buffer in our platform allows that CPU to be off longer, which is going to translate directly into longer battery life. So that's also what the visual enhancement engine is about. Not only is it about improving that picture like I showed you earlier or video on your phone, it also allows you to run your display at a lower backlight. Again, lowering backlight, lower power, lower energy, longer battery life. So it ties very well into these key requirements of mobile devices. And then, of course, the MDDI client. Now, this is an example of what I talked about earlier. You can't just deliver a fully programmable platform and expect to get designed into these certain subsystems of mobile devices. At some point, you have to make a bet and say, I'm going to purpose this silicon for this specific subsystem. And by embedding MDDI directly with the PHY, we've fully purposed this platform to be in the display path of these Qualcomm-enabled devices. So that's the new platform announcement. From an ecosystem perspective, we do work very closely with some of the processor or baseband companies to make sure that we're architecting these correctly. Qualcomm, obviously, for the VX4 that we just announced. We've been working with Intel for quite some time, as you've probably seen in some of our press releases, and also Marvell from an application processor standpoint. In terms of our manufacturing partners, we have Amkor, Unisim, TSMC, and Tower. And in terms of the VX4 launch that we just had, we had to work with a close group of companies to, again, make sure that the technology and the architecture was correct for this. So we work with Micron, as you'll see in the press release that hit the wire this morning, on the frame buffer technology. We use the very low power cellular RAM technology from them. Apical is the original company that designed the engine that's behind V, underlying V, and we work with them on V2.0. Mixel is our analog PHY partner, and then Wipro, of course, has helped us with the design of the platform itself. And if you go back to the original CSSP value proposition, one of those things is it's a complete solution that includes software drivers, so we have to work closely with folks that know software drivers and operating systems very well. For example, the ones in the mobile space like Android and Microsoft and Linux and so on. So to tie this back together, we are innovating new PSBs, new system blocks, and new silicon platforms all the time so that we can come out with CSSPs that address these emerging requirements of this exciting netbook MID space. So the announcement today, I think, is hopefully proof of that with V2.0, MDDI, and VX4. What that translates into are that OEMs and ODMs in this really exciting high-volume space now have something that can help them sell to their customer. And again, that goes back to the data plans that these operators need in order to thrive. And behind that, of course, is the user experience and the battery life that we all expect these devices to have when we buy them. Thank you.